We're hitting a quorum, but let's go ahead and get started. Today, we're going to be talking about the Studio System 2, which is really Desktop Metal's next generation of in-office metal 3D printing. My name is Rejto. I'm a technical marketing manager here at Desktop Metal, and I'm excited to talk with you all today. I quickly just want to start with a poll. I'm very curious to hear, what benefit are you hoping to get from metal 3D printing? Are you hoping to save time, save money? I'm sure many of you will select that option, but then there's some more specific things. Do you want to produce, better parts, maybe stronger, lighter, optimized? Do you want to do mass customization? Do you want to, make changes to your inventory and your supply chain? I'm curious to hear, what benefits are you hoping to get from metal 3D printing? Getting a nice distribution. A lot of people saying better parts, which is great because it's one of my favorite things to talk about is all the great design features that are possible with the Studio system. A lot of people who want to save time and money, of course. All right, we'll give this a few more seconds here. All righty, let's jump into it. Alrighty, so today we're talking about the Studio System 2, which is really the easiest way to print metal parts. If you're familiar with the Studio System 1, which we launched a few years ago, that used to be a 3-step process, but now we've been able to simplify this process into just 2 steps. Simply print and sinter. You can see the system behind me here, and you can see I no longer have a debinder. I just have a printer, a furnace, and that allows me to create complex metal parts in my office environment. Just print and sinter. We're going to talk a lot about how this works, but all in all, what does this do for our customers? It allows them to shorten their lead times, reduce their part costs, and unlock this new design freedom to build these incredibly complex, beautiful parts, but in metal. And you're doing all of this with this unrivaled level of accessibility. It's very easy to use. It's very safe to use. It exists in your office environment. So before I jump into all of the benefits and what's new with the Studio System 2, I briefly need to talk about the Studio System 1, which is really the origin story. It's the first printer that Desktop Metal launched. We launched this printer back in 2017, and it was the world's first office-friendly metal 3D printing system. The Studio System 2 really stands on the shoulders of the Studio System 1, so it's important to talk just a little bit about what made the Studio System 1 so great. The Studio System 1 delivered these high quality, accessible, and easy metal part manufacturing, but for the first time in an office environment. The machines were sitting right next to where you were working with your designers, with your engineers, allowing them to create these beautiful, high quality parts, but with unprecedented levels of accessibility and ease of use. The Studio System removed many of the challenges of traditional metal 3D printing, with your laser powder bed fusion machines like a DMLS machine, but the Studio System really removed many of the challenges that were involved with those systems. For example, no loose metal powders at any point during the process, which meant you didn't require any respiratory PPE to use the system. There's no dangerous lasers involved. You didn't need any third-party equipment. We provided everything you needed to use to get up and running printing high quality metal parts. There was no highly trained dedicated operators. Anyone on this call could learn how to use the Studio System very quickly, very easily. It was targeted to be used by engineers, by designers, very simple to operate. There was no welded supports during the process, which is very common with DMLS or laser powder bed fusion, where your supports are actually welded to your part and they have to be removed with saws and mills. But with the Studio System, these supports could all be removed by hand. And again, no special facilities requirements. This system was built to go into the office environment where your designers, where your engineers are working. The system really allowed our customers to push the limits of design and manufacturing. You can see, a wide variety of different part examples you're seeing on the screen here, but really a lot of different applications. And important to note that we saw a wide variety of applications, from everything from, the automotive industry where it's common for them to be producing manufacturing tooling and end-use automotive parts, all the way down to some consumer products like jewelry, like fine jewelry. There was really a very broad range of applications for the system. It wasn't just one application. It was very broad. And of course, This technology was being embraced really all over the world. As I sit here in our office in Boston, Massachusetts, we really have seen an incredible reach with the Studio system being all over the world and having impact all over the world. Just a quick quote from one of our customers of the Studio system, Jason Hargo, who's a design manager at Johns Inc. Hamburger Combustion, saying that the Studio system was a total mindset shift for their engineers, allowing them to greatly drop their prototyping costs and turn times, allowing them to really open up new ways to think about design. I love hearing this quote, just the fact that the Studio system was such a mindset shift for their team. But of course, today we're here to talk about the Studio System 2. The Studio System 2 is really taking the Studio system to the next level. It's building on that success and making the system even better than before. Studio System 2 is easier and more accessible than ever before, now only requiring 2 pieces of equipment with a 2-step process, print to sinter. First, let's talk about how it's more accessible. Like I just mentioned, you're going to be able to create these complex, high-performance parts in just this breakthrough 2-step process. With Studio System 1, the process required this solvent debind phase. That's no longer required with Studio System 2. The parts go directly from printer into the furnace. It's a very hands-off experience, entirely software controlled, allowing for very, very, very little hands-on time for fabrication of even the most complex parts, making it very, very simple. I'm probably going to say this 20 times during this presentation, but the Studio System 2 really enabled very, very accessible, easy to use print to sinter technology. So how did we actually remove these solvents? This was done through a newly engineered material platform that was able to eliminate the need for a debind phase and allow for a thermal debind. What are some of the benefits of this, of not requiring solvents? Of course, you no longer have any EHS concerns around odors or solvents. You don't have those environmental health and safety concerns around that debind fluid that happen with some organizations. The system is now easier to install, requiring less footprint, thanks to only requiring 2 pieces of equipment, of course. You just have the printer and the furnace. You're seeing a reduced consumable usage because now we don't have to worry about any of our debind consumables. And all in all, it's just an easier process requiring only 2 steps. So how does this system actually work? You can see the printer behind me here and the furnace over my left shoulder here, but we start in the printer. The printer starts by extruding these bound metal rods. You can see I have one here in my hand. This rod is a combination of metal powder, a steel powder, or whatever material you're printing, combined with polymer binders. This is a process we call bound metal deposition, and what it results in is a green part. You can see I have a green part with me here today. This is what comes off the printer. It's that combination of metal powder and those binder materials. From here, the part is still relatively fragile. It's safe to handle, but if I were to drop it, I could probably break it. But from here, we go into the furnace. The first step in the furnace is to remove that binder material. We're going to get to a temperature where that binder is able to be evaporated, and then what's left behind is that metal powder. We get just below the melting temperature of the material, and our particles actually fuse together, causing the parts to densify up to 98%. The part does shrink about 15% during this process, but of course, that's fully controlled by our software to ensure you're getting the desired dimensions that you require. So you can see, we have our green part that's coming off the printer to our final sintered part here. That's the metal we want. So the result of the furnace is what we're seeing, these strong, dense metal parts. And you can hear, this is now a strong, dense metal part ready for those end use applications, ready to be put into the field. The next big improvement with the Studio System 2 is really allowing for better parts. We have these newly improved material formulations and updated profiles for both the printer and the furnace to allow for best-in-class part success, part quality, and material properties. Starting with reliable processing. With major process improvements, the Studio System 2 is designed to deliver parts consistently the first time. You're seeing excellent first-time part success, which is able to reduce the trial and error process that's common with other metal manufacturing processes. I'm confident that when I upload my part to the printer, it comes out of the furnace, it's going to be the geometry I need, it's going to be the quality I need. Of course, you're still seeing that very, very, very wide range of geometries possible because it's an additive process. We're printing our parts up layer by layer, allowing for even the most complex geometries to be produced with ease. You can see a few geometries here. These geometries are, quite challenging traditionally, but are now highly successful with the Studio system. For example, this part that I have here, very thin, flat surface attached to a large mass. This can be difficult to sinter, but thanks to these new material formulations and new profiles, now a very, very successful geometry on the Studio system. Another example on the right here, you can see those thin walls attached to those large outer mass. They're quite tall, they're quite thin, previously quite challenging to sinter, but now highly successful on the Studio System 2, thanks to these new material formulations and new print profiles. Another addition or change with the Studio System 2 is this new gyroid infill and supports. The Studio System 2 parts now feature a gyroid geometry both in the internals of the part as well as for any support structures that are needed. This has benefits for both the process as well as the part. This gyroid is continuous in X, Y, and Z, which allows for a very efficient thermal debinding of the geometry, allowing you to very efficiently remove all that binder material out of your part. It's also a very high strength infill, making it perfect for you to produce very strong parts for those end use applications. In terms of support structures, when you do need a support structure, those supports are now printed with that gyroid, which allows for both a faster part printing, a very efficient thermal debinding of those supports, and it actually uses less materials on the supports now, which ends up with a reduced part cost. So the gyroid, has some benefits for both the part as well as the supports for that part. That gyroid infill also leads to faster fabrication of thick geometries. Thicker geometries now have a faster total processing time, thanks to that very efficient thermal debinding that I mentioned of both the supports and the infill. You can see that brick housing on the left, you're seeing almost a 50% reduction in total part processing time. Another example here, you can see this is quite a thick geometry in this large gear, seeing a 15% reduction in time, and the pump housing on the right, a 34% reduction time. So it's great that gyroid is able to give us faster processing time for these thick geometries. Improved part quality, of course, thanks to these newly engineered print profiles and also some changes to the actual hardware, we're getting this excellent feature resolution and part quality. You can see I have some of these tiny parts. We'll see how still I can hold my finger, but some of these beautiful, I don't know if that's focusing, but some of these beautiful small parts, this was printed with that 250 micron nozzle, but super, super high part quality, thanks to these optimized print profiles that allow for that beautiful part quality. This heated chamber that's built into the printer, which allows for a very controlled print environment for high quality printing, thanks to that better adhesion, and a newly updated print head with a new coating to ensure that fine feature resolution. See, we'll try one more time to show you these this part up close. It's so teeny, but you can see that beautiful feature resolution on this small part. Lastly, talk about the improvements to surface finish. Thanks to this new material formulation, as well as newly engineered print profiles, there's quite a large improvement in terms of surface finishes on all sides. We're seeing very, very minimal stair stepping, which is, a nature of an extrusion-based process on sidewalls, thanks to some excellent improvements in the profiles. You can see on the side of this part, again, not sure how well that's focusing, but very, very smooth surface, as well as excellent surface finish on downwards facing surfaces that are coming off of supports. It's very difficult now to tell which direction a part has been printed because the surfaces are so excellent. This is thanks to some improvements to the ceramic interface that allows for a better removal and a better surface finish on those supports. So let's quickly talk about the hardware. As I mentioned, two pieces of equipment. We have the printer first. The printer allows for this excellent print quality, optimized print profiles that are automatically built into the printer, allowing you for very, very easy part fabrication. Just upload your part, select a print profile, and the printer is going to start printing. It's got that heated build chamber to help with the part quality, as well as a vacuum hold bed to ensure your part is securely fastened to the base of the printer to allow for very high quality printing. It's a very smart system, which helps with the accessibility. It helps with the ease of use. It's an entirely software controlled workflow. You're going to get process alerts when jobs are complete. We have an optimized orientation calculator, which means as you upload your part, all you have to do is click an auto orient button. It's going to orient that part for both printing success as well as sintering success, making it super easy for you to fabricate parts. And then again, we have this second generation of separable support structures that allow your parts to be easily removed from their supports by hand. The build area is about 12 by 8 by 8 inches. We have both a 250 micron nozzle and a 400 micron print head, allowing you for both, fast printing as well as very high resolution printing. And you can see similar with the layer heights between 50 and 300 microns, adjustable layer heights. The furnace. The furnace is an incredibly impressive piece of equipment. It's incredibly user-friendly, allowing you for a fully software-controlled workflow. Fabricate, which is kind of the brains of this whole operation, is going to ensure your sinter cycle is optimized for your part success. You have a fully accessible retort that can be removed from the furnace to allow for very easy positioning of parts inside of the furnace for optimal success. At Desktop Metal, we're doing lots of work to qualify new materials to improve part performance. So as we're rolling those out, we're going to be able to send those to you over the air for over-the-air sinter profile improvements to ensure you always have the best sintering profiles. Of course, this allows for very high performance thermal debinding and sintering. It's possible for this furnace to do a complete thermal debinding, like we've talked about today, meaning you don't have to have any solvent debinding, any separate solvent debinding process, and of course, delivers high densities and excellent material properties. One of the best things about this furnace is that it's a very office-friendly sintering furnace. It's going to fit through your generic office doorway, meaning you can just wheel it into your office, and it uses a vacuum-assisted sintering cycle, allowing for gas usage as low as 850 liters per cycle, which is going to save you both costs, as well as you're not going to have to replace the gas very often. Retort size matches the size of the printer, 12 by 8 by 8, has stackable shelves, so you can put multiple layers of parts. Peak temperature on this furnace is 1400 degrees Celsius, which allows for sintering of a wide variety of alloys to the highest material properties possible. And it can use both argon and then argon hydrogen blend, depending on what material you're sintering. Important to know, this furnace is also compatible with the shop system, which you can see here to my left. So if you decide you want both systems, they can share a common furnace. Looking at materials, the system is really designed to offer a material for every application. We're launching with 316L, followed very closely by 17.4pH and D2 tool steel. Currently, you can also have these backward compatible materials that have been available already on the Studio System 1, which is 17.4pH, 4140 low alloy steel, H13 tool steel, and copper. Those materials are also available for the Studio System 2, but currently require a solvent debind. But we're working very, very hard, very quickly to release more of these materials in that Studio 2 formulation that allows for this no solvent debind. Just a little bit about 316L. 316L is an excellent general use stainless steel. It has very high mechanical properties as well as excellent corrosion resistance, making it a great general use steel for a variety of different applications. You can see some of the material properties here. You can see them compared to NPIF 35 standards as well as the rod values, and you can see that in terms of ultimate and yield, we're right there above the NPIF standards and actually above wrought material as well, allowing for some excellent material properties that you need for those high stress, high heat applications. Like I mentioned before, 316L stainless steel is an excellent material for a wide variety of applications. We're seeing our customers very interested in producing a lot of different parts, everything from fixtures and manifolds, even to some jewelry components and housings and latches. Lots of valve components and impellers, just to give you an idea of really just all the wide variety of applications that are possible with 316L stainless steel. So I've covered a bit about what's new with Studio System 2, and what are some of the new features, what are some of the applications as you're seeing here, but what does this actually mean for you? What is the Studio System 2 going to do for you? The Studio System 2 is going to allow you to change the way that parts are designed. Currently, you can see this end effector here, the part on the left with the CNC machine design, and you can see it's bulky, it's big, it's heavy. This is really because this part is being designed more for its manufacturing method than it is for its actual application. With the Studio system, you're now producing with an additive method. You're building the parts up layer by layer, allowing you to do these innovative new designs that feature these lightweighting features, organic shapes, allowing you to really design your part to be optimized for its application and not have to worry as much about how it's going to be made, because we're able to print it very, very easily. So Studio system is going to open up all these new design features for you, allowing you to change the way your parts are designed. It's also going to change the way your supply chains are managed with on-demand replacement parts. You can see an example here of a part that was produced by one of our customers, John Zink, back in 1967. When a replacement part was needed, of course, the foundry was no longer operating that had originally cast this component. So what do? They grab the part file, they upload it to their printer, and in a couple of days, they have a solid metal part ready to be sent out into the field. This idea of having these digital inventories, allowing you to really transform your supply chain, not have to worry about tooling, allowing you to do on-demand replacement parts, really allow you to change the way supply chains are managed. Another great application, of course, is prototyping. But now we're not just prototyping for form and fit, like so popular with plastic 3D printing, where I'm going to print my part, I'm going to put it into my machine and see if it fits. But now I can actually functionally test my parts. I can see if they can withstand this high loading, this high heat, corrosion environments, to really understand how this geometry is going to perform before I move to my mass production method. So by being able to prototype in metal, we're going to be able to change the way your parts are prototyped, ultimately leading to a better final design mass produced. What does this mean for your organization? So if you're a machine shop, Studio System is really going to allow you to modernize your shop with this new agile hands-off production tool. Many of our customers for the Studio system were manufacturers, and what are they using the system for? They're producing lots of tooling, producing jigs, fixtures, tooling, both faster and more efficiently, allowing them to reduce part costs and lead time both on that tooling as well as the parts that they're creating, and ultimately allowing them to bring up new manufacturing lines faster. When it comes to complementing these existing traditional manufacturing methods, we're now able to print these new innovative tooling designs. Do things like conformal cooling channels, where we're able to snake channels throughout the part to increase cooling rates and reduce cycle times for injection molding. We're able to lightweight fixtures to reduce wear on our robotic arms and allow our equipment to actually run faster for a more efficient manufacturing environment. We can do things like conformal jaws and assembly fixtures for machining and assembly to allow for higher throughput on our machines and higher throughput through our assembly lines. And even things like custom press brake tooling, where traditionally we may have had to have no bid on a job because it didn't make sense. We couldn't justify producing the tooling in low volumes. But now we can simply print that tooling for a low cost, quickly and affordably to start bending that sheet metal for these low volume custom jobs. Lastly, depending on the volume you're producing in, it can make sense to simply just print the parts rather than machine them. The system, of course, requires very little operator burden and no non-recurring engineering time to print. Simply upload your file. It can run over the weekend. It can run overnight, allowing it to do all the work for you while you're busy doing other things. Again, no specialized trained operator required. You can print a part that would take, a master machinist knowledge with very little effort on your own part. You can quickly print a handful of highly complex parts, generally at a reduced part cost. And with machine shops, of course, tolerances and surface finishes are an important thing to consider, but you can easily touch up these critical dimensions on a simple 2.5-axis mill rather than having to go to a more complex, more expensive machine like a 5-axis mill. Important to note, when these parts come out of the furnace, they're metal components. They can be finished the same way any metal part would be finished if you want to machine them, if you want to weld them, if you want to plate them, mass finishing like tumbling operations, sandblasting. These parts are fully compatible with traditional finishing operations. For those of you that currently have print farms at your organization, the Studio system is an excellent way to bring metal 3D printing into your print farm. It's built to be highly accessible. It makes it an easy addition to your farm. Of course, with the Studio system, since it's so accessible, you're now able to give your employees hands-on access, allowing them to control the print queue as well as part creation. This is going to allow them to be very, very efficient, very, very agile, and be able to efficiently produce these complex metal parts for themselves. The technology is very easy to use. It's based on familiar FDM or FFF 3D printing, allowing for some of the very similar design guidelines. And again, no highly trained operators. You're going to train your employees to use this system, and it's not going to take them very long to get up and running. I like to say this, I think I could train anyone on this call to get up and running with the Studio system in just 10 or 15 minutes. We could be printing your first part. And ultimately, why do you have a print farm in your organization in general? Is for all those benefits of 3D printing. But now with the Studio system, we can unlock those benefits in metal. Get that great design freedom that's possible with that additive nature with metal. Be able to do on-demand manufacturing without any tooling. You're going to simplify those manufacturing logistics and ultimately reduce lead times and part costs. At Desktop Metal, we really feel that the engineering organization in the future is going to have a big emphasis on metal 3D printing and 3D printing in general. You're already starting to see it at many engineering organizations where you're seeing plastic printers strategically located throughout the office, similar to how you would see an inkjet 2D printer. But we really feel that this is going to start happening with metal 3D printers. These systems are designed to be in your office environment. They're designed to sit next to you. I mean, my desk is right across from me here, and I sit by this printer all day long as I finalize the design, upload it, get it printing as I'm working. Allows your employees to have hands-on access to produce these prototypes like we mentioned, quickly and affordably, ultimately leading to a better final product. They can do, if you're a manufacturer, do things like real-time tooling and digital tooling, allowing you to reduce costs and lead times, because whenever you need a tool, simply finalize the design, send it to the printer. Print and use parts for your everyday needs. We see a lot of this in machine design with brackets and housings without the need for any tooling, without the need for any logistical hassles. Ultimately allowing you to bring your products to market faster, more efficiently, and more affordably while delivering a better final product. Okay, so that's some of the big vision stuff about Studio 2, where we see it being utilized, where we see it going. But let's look at some specific parts and talk about what they are, why it made sense to print them, and how much they're going to cost. Quickly looking at just a few of the key use cases that we're going to be talking about in a moment here. Low volume end use parts, like I was just mentioning, for your everyday use in your office environment or on the manufacturing floor, things like brackets, housings, fixtures. Tooling, of course, some of the most expensive and longest lead time components to create. Awesome application for metal 3D printing, especially on the Studio system, to be able to drive those costs down, drive those lead times down. Research and development, but now we're not doing form and fit. We're actually functionally testing our R&D parts to see how they perform. Replacement parts for, maybe you have something break in the field, rather than having to go to a manufacturer or go to your machine shop, just load the part on the printer. You'll have it in your hands in a few days. Functional prototyping, like I mentioned, not just form and fit, could actually test these parts under high loading, heat, corrosion to see how they perform. And of course, jigs and fixtures, almost always produced in low volume, almost always quite expensive. You can save lots of time and cost by simply just printing these parts. So let's start by looking at some tooling and manufacturing floor applications. First part I have with me here is what we call the flower nozzle. I'm guessing you can understand why. It kind of has these bulbs surrounding this inner surface. You can see that bottom there. This is used to atomize a fluid in an industrial equipment operation. Due to this complex geometry of this part, typically this part would be cast, followed by some extensive secondary machining. But since it is for the manufacturing floor, it only needs to be created in low volumes, making it a perfect part with very high complexity, low volumes, a perfect part to be 3D printed on the Studio system. 316L was also an ideal material for this part, thanks to its superior corrosion resistance for that manufacturing environment. This part can be printed for just $158. It's a pretty cool part, so I hope it's coming across okay here on the webcam, but just another great example of parts printed on the Studio system. Okay, another part for the manufacturing environment is this laser gas nozzle. This part is actually attached to a laser cutter to help flow an inert gas over the cut to help prevent slag, as well as reduce clogging of the actual laser cutter nozzle. This part actually features a design that's only possible to be 3D printed. It has some internal passageways to help direct the flow of that gas that were not possible to be created with any other manufacturing method. Of course, this part, or not of course, but this part was previously printed in PLA plastic, but it was melting quite often at higher temperatures from the laser. So the customer decided to go into metal with 316L, allowing for a part that can be used indefinitely. This part, another great example, can be printed for just $99 on the Studio system. Another great example here of some of that cool manufacturing floor geometry of some of the innovative new tooling designs that are possible. Another part for the manufacturing floor is this auger. This auger is used to advance some pellets in a manufacturing environment, some material. It features this kind of cool double helical geometry, one being the protrusion and then the other being the deboss. This would require some advanced CNC lathe operations to produce. Again, for the manufacturing environment, only a few of these augers were going to be needed, so it didn't make sense to go out of house to produce these rather than just printing them on the Studio system. Able to print all the parts that were needed for that operation in less than a week on 316L stainless steel for just $62. Of course, to machine these parts would require a highly trained, dedicated operator, someone with a lot of skill in manufacturing. So it made sense just to load a couple of them up on the printer, print them in a day or two, get them in the furnace, and you're ready to install them onto the manufacturing floor, which is another good example. Okay, let's look at some replacement parts and one-offs. Part I have here is this punching machine bearing housing. This part was originally designed for CNC machining. You can see the top part there on the screen, but once they had access to the Studio system, they decided it was optimal to simply print this part instead of machining. Once the decision was made to print this part, you can see they were able to do lots of optimization to greatly remove lots of mass and unnecessary material to allow this part to be optimized. They did this with a topology optimizer, and of course, that led to significant lightweighting. One of the great things about 3D printing is that when you're doing lightweighting and topology optimization, you're actually reducing your part costs. With any other manufacturing method, increasing the complexity like this, increasing the number of these cutouts and these organic shapes is going to drastically increase your part cost because now you have more cuts, you have more mold complexity. It's going to increase the cost of your part. But by doing this with a metal 3D printed part or any 3D printed part, we're now able to reduce not only the mass, but also the cost and the print time because it's less material usage, it's less print time usage. So a great example here of a replacement part for this punching machine with this bearing housing, printed in 316L for just $163. Hope you can get a look at this. And this is a great part with some very beautiful surface finish. Another part that I mentioned earlier is this electric bike bracket. Again, this part is used to attach a motor, a battery, and a gear set to an electric bike frame. This part was also originally designed to be machined out of two separate components. It was going to have one that was this flat plate here. It's going to be more square and solid, of course, and then this solid cupped component that was going to be used to attach to the actual bike frame. With access to the Studio system, they made the decision to redesign this part and consolidate it into just one part. So no longer do we need any fasteners or any assembly for this component. Also, now that we're printing the part, we're able to incorporate all of these lightweighting cutouts that would have added drastic costs if the part was to be machined and would have been left out. So the benefit of these is not only just lightweighting the component for this e-bike, which of course is important so the battery lasts longer, but also reducing the processing time and reduces the part cost. This part again, printed in 316L for just $169. So a great example. We have a manifold. Manifolds are an awesome application of 3D printing and metal 3D printing specifically. This part is used as a gas manifold. It takes one house gas supply and distributes those to a variety of different locations around the building. Manifolds are, typically quite challenging to create simply because we're limited to only drilling straight holes. So manifolds are usually assemblies or welded together. They require, drilling of straight holes. And then you have holes that are plugged to ensure that, you get the channels you can need. But with metal 3D printing, of course, we're building up the part layer by layer. So it's no problem to incorporate those channels right into the part. You can see the rendering I have on screen, and you can see those complex channels that are built right into this part. Very efficient and very affordable to simply just print this manifold rather than going through that multi-part assembly that would be required. Again, produced in 316L for a cost of just $164. Okay, the last replacement part we'll look at is another manifold. This one here, of course, is used for fluids. It's going to converge three fluids into one common flow coming out of the top. Again, this part features some very complex internal channels that would be impossible to machine because they're snaking throughout the part. By printing on this part, the designer was able to really just think about what's the best way to, have these three channels converge rather than have to worry about, the tedious manufacturing operation to really bend to the will of traditional manufacturing. This is one of the larger parts we talked about just now, but, again, 316L for just $268 and can be printed in just a few days, put into work with very little hands-on work, of course, because the printer is going to run in the background with no operator, allowing me to, produce this part with very little hands-on effort. Okay, lastly, we're going to talk about functional prototypes. I have this connection linkage here. This is used in a machine design application to connect two different sub-assemblies together. When this part is finally produced in high volumes, it's going to be cast. But before we actually move to that casting stage, before we move to a foundry with potentially 4 to 8 month lead times, we want to be able to test this geometry to ensure that we're positive this is the right geometry we want to go with. By prototyping this part in metal, we're not just going to see, oh, does it fit into our machine? Now we can see how does it perform? How does the geometry actually perform under high loading, heat, corrosion environments to really understand, is this the right geometry to move to higher volumes with? Again, produced in 316L for just $22. To outsource this component to a third-party manufacturer, because it would be outside the capabilities of their machining, is going to cost $979. So a huge cost savings, as you can see, for producing this linkage here. It's a cool, complex part. This turbine blade holder. So this is a smaller part. It's used to secure a turbine blade in place while it's experiencing some flow testing to validate its geometry. Again, for the testing, for the prototyping environment, only 3 of these parts were required for 3 different blades. So this low volume meant that all 3 of these parts could be printed in just 7 hours. They then need to go into the furnace. But if I finalize the design of this part at the end of the day today, I can load it on the printer, and tomorrow morning I'll come in and they're ready to go. It features some small features that would be difficult and time consuming to machine and was outside the capabilities of the lab. So it would have had to have been outsourced to a third party manufacturer, but thanks to the Studio system can simply just load this part up onto the printer and get it printed at a reduced part cost and lead time. This is a relatively small part as you can see, produced in 316L for just $8. A traditional cost to outsource this part was going to be $373. So again, 98% cost savings here, a really, really big cost savings here for this prototype. Lastly, we'll talk about this knock sensor holder. This part holds a knock sensor in place in the car to ensure it actually is an audible sensor to ensure that nothing's knocking around in your engine. Again, when produced in high volumes, it will be cast followed by post machining. But during the prototyping stage, the Studio system was very beneficial to ensure that the part was the adequate geometry that was actually put into the engine to ensure it was going to operate correctly and was optimized before placing this casting order and waiting 6 to 8 months for your first parts. Again, only cost was $15 here. So very, very affordable, very, very quick to produce. All right, so to quickly wrap up before I take some questions, and I see there's quite a few questions coming through, so I'm excited to see what everyone is thinking about. The Studio System 2 is really the easiest way to print metal parts with this 2-step process, print and sinter, allowing you to greatly shorten your lead times, reduce your part costs, and unlock this unprecedented level of design freedom to be able to create these highly complex parts in your office environment. You're doing this all while maintaining unrivaled levels of accessibility. There's no solvents involved, no loose powders, and of course, no lasers involved at any point during the process, making it very, very, very easy to use. It's my favorite 3D printer I've ever used. I have one right here near my desk. I use it almost every day. We have, of course, many of them in the building, and they're constantly being used by our engineering teams and everyone in the building for prototyping and other reasons. It's really the easiest way to print metal parts. It's an awesome machine. So now that I've talked to all of you, I thank you all for joining me and listening. I'm curious to hear, what is your additive manufacturing use case? What are you hoping to use metal 3D printing for, or 3D printing in general for? Are you looking to do some of that prototyping we talked about? Are you looking to do mass production? I'm curious to hear, what are you looking to use 3D printing for? seeing a good distribution here across all of these categories. So that's good to see that I picked some relevant options, I should say. Give this 15 more seconds here, and then I'll jump over to some questions and see what everyone's thinking. Alrighty. Lastly, thank you very much for joining me. I'm happy to take some questions now. I should say, feel free to shoot me an email at any point if you have any thoughts, comments, questions. I'm happy to chat with anyone here. I like to say this, but I really learn so much from talking to prospects, talking to people out in the field to understand, what are you manufacturing? What are you designing? I love learning about manufacturing. So I really feel I learned as much from you as you can from me. I'm happy to look at some of your parts, talk to you about your manufacturing situation, see where some desktop metal products could be a good fit. Feel free to shoot me an email if you have questions, or shoot me an email if you want to schedule some time to chat. I'm more than happy to do it. But at this point, let's take a look at some questions and see what people are wondering.
All right, so plenty of questions coming in. I think there's a few common ones we'll hope to address. Ethan, if you could start, we'll start materials. So can you talk a little bit about, I guess, first off, the materials that are available for Studio 2 and Studio 1, and kind of what the differences are between those? Can you use one or the other, et cetera?
Sure.
And then with a follow-up to specifically a few questions around aluminum and questions around parts for jewelry.
Sure. So let me, if I can find my cursor here, just going to jump back to the material slide. Oh, my computer has a mind of its own right now. Okay. Sure. So as I mentioned earlier, as the parts come off the furnace, you're seeing what's called a green part. This is that combination of metal powder and polymer binder, the metal powder being our material. So, this part here is 316L. So this features 316L metal powder, but it's fully encased in binder, making it very safe to handle, very safe for the office environment. As I mentioned, there is some shrinkage involved. There are quite a few parameters that can be tweaked during printing and during sintering. So, as we're, figuring out those properties, as we're developing these materials, we will be releasing them to you. We want to ensure that when we put, these materials in your hands, that you're right away able to be successful. It's accessible and easy to use. But we want to ensure that there's no guesswork on your part or any extra work on your part. You can simply select the profile we've made for you and start printing. What does that mean? That means that today we're launching for Studio System 2 materials with 316L. This summer we'll have 17.4 and D2 tool steel coming out. We do have these materials that are already available on Studio System 1, 17.4 pH stainless, 4140 low alloy steel, H13 tool steel, and copper. Those materials are also available to be printed on the Studio System 2, but they do require a solvent debind. So to print those materials today, you would need that solvent debinder. But in the near future, we're quickly working to get those materials out, and you'll see those materials be released in Studio 2 with without that need for that solvent debind. So
great.
Hopefully that sort of answers the question about aluminum. It's one of the most common questions I get is, can you print aluminum? When will aluminum be available? This is a sintering technology. It's based on powdered metal and sintering. There are some challenges with sintering of aluminum. You can do some research online about it, but aluminum is a very, very difficult material to be sintered. That being said, when I talk to prospects or customers about aluminum, their answer for why they want aluminum is generally because it's easy to machine, it's inexpensive, and it's lightweight. Of course, now we're printing our parts, so many of those benefits are no longer true. We're not machining, so we don't care about ease of machinability. In terms of lightweighting, we're able to incorporate things like infill into our parts that drastically reduce weights of our parts while still getting that strength of steel. And in terms of cost, of course, now we're printing, it's a different material, so it's a different option. So that's kind of my answer when people ask about aluminum. I wouldn't expect it anytime soon. And also, why do you really need it? And can you use things like infill and new geometries to leverage that strength of steel while still getting those same benefits of aluminum?
And then a question on parts for jewelry. How have we seen those get done via?
Sure. So with the Studio system, we've seen quite a bit of custom jewelry being done in terms of just these innovative new designs that can't be produced in any other way that can now be produced in low volume. Things like rings and bracelets and ornaments for necklaces and luxury goods are all great examples of things that are being done on the Studio system, and we're seeing them commonly being printed and sintered. Then you see some mass finishing, some polishing operations, and then they can even be plated with gold or silver or platinum or whatever luxury material you want. Or they, I think the parts look pretty great as steel as well. But jewelry is an awesome application because they're really able to take advantage of the design freedom that's possible thanks to the additive process.
Awesome. Then a couple of questions on keep going on the materials thread. Can you talk a little bit about part properties? What sort of might they be similar to from traditional manufacturing that people are used to?
Sure. So as you can see, part properties here, the parts perform very similarly to a metal injection molded part. So you're seeing, we exceed those MPIF standards that are required for, those metal injection molding standards. In terms of surface finishes, I'd say we exceed what you'd get from like a high quality casting, allowing for those excellent material properties. And I mean, properties kind of speak for themselves here. We're really seeing very similar properties to MPIF NIM standards as well as for wrought materials. So parts are great for end use applications. They're great for tooling. They're great for fixturing. They're really strong, dense, strong metal parts.
And then what about post-processing, heat treating, plasma nitride, things like that?
Sure. So like I mentioned earlier, when the parts come out of the furnace, they're strong, dense steel metal parts. At this point, you can do anything you want to them in terms of, probably the most common thing to do would be a secondary machining operation to touch up a critical dimension. Still tons of value. I mean, imagine this pump housing, how much easier it is for me just to post machine this slot rather than have to machine this entire body out of a wrought block of 316L. If I want to put this part into a mass finishing, a tumbling operation with an abrasive media, no problem. If I want to weld it, if I want to heat treat the parts, it's going to behave the same way a 316L stainless steel cast part would or wrought part would. So all those traditional mass finishing operations or finishing operations in general are possible now. If I need to tap some holes, whatever I want to do.
And then specifically on the post machining for sort of threads or holes, can they ream a hole and what do you deal with threads?
Yep. So actually, this part has some tapped holes in it. I don't know if you can see. Generally, depending on the size of the hole, if it's below a 1/4-20, I'm sorry if you're a ISO, if you're a metric person, but if it's below a 1/4-20, I guess that'd be like an M10. We recommend just printing the hole and then tapping how you normally would. If it's larger than that, you can actually print the thread right into your part, like I have here on this larger thread. I don't know how well it's coming across in the camera here. You can actually print that thread right in your part and simply just run a tap through it afterwards to clean up those threads to ensure that you're getting that good tight cut and fit that you need. So threads, fully applicable to these parts.
Great. And then one other on waterproof or leak-proof parts. Are they waterproof and leak-proof?
They are to a set pressure. I don't know the exact leak-proof test that we have performed, but I know it exceeds some standard. If you want to shoot me an email, I can look up that number for you and get you the PSI that these parts have been leak tested to.
I think I actually have it here. So I think we've done up to 220 PSI for watertight and airtight up to 100 PSI. But to note that those parts were not tested to failure. They were just tested to the need for the application. So certainly may be able to withstand more pressure than that. Also, I'll say that as always, and with many things that we have here with printing, it's greatly geometry dependent. So there are certain things that you can do, I'm sure, to improve those numbers or have things come out the way you need them to. Great. So a lot of questions that we've covered. Can you talk a little bit about processing time, how that sort of splits up between the different parts of the system?
Sure. So the processing time is really dependent on, first you have your print time. So for example, a part like this may take 15 to 20 hours to print. And then it's going to go through the furnace cycle. The furnace cycle is dependent on two things. The first being the thermal debinding step, because the first step here is going to be to remove all of the binder out of this part. That's going to be done at a lower temperature in the furnace, and we need to ensure we get all that binder out of the part before going to a high temperature. That can take anywhere from 5 hours to 50 hours to 70 hours. It really depends. Important to note that that's a batch process. So I could fit, 10 of these parts into one furnace run at once. So if I wanted to print 10 of these throughout the week, put them all in on Friday, it could be done on Monday morning and, ready to go, all 10 of those parts. So it depends on how big the part is, how thick the part is. Like, for example, a part like this, may only require a 2 or 3 hour thermal debind compared to, something that's very, very thick like this may require, potentially up to 50 hours. But important to know that it's a batch process, it's a hands-off process. So I'm going to put, a bunch of parts in the furnace at once. I can come back a few days later. They're all going to be ready to go at the same time. So it's great in that regard. It can be doing all the work for me while I'm sitting on the beach or playing golf.
All right. And then can you talk a little bit about part size? Some people are noticing that some of the parts you have there might be bigger than our recommended part size, the 150 by 150 by 110. So can you talk a little bit about how big can you kind of go, and what are the things that you have to consider when making?
Yeah. So, we do have a recommended part size. That part size is to help ensure part success as well as good part economics. That being said, there are some situations where you can go larger than that and it still makes sense and your parts are still highly successful. For example, like this part here is probably about the largest part we would suggest doing, or it is the largest part we would suggest doing. And a large part of that is due to its actual mass. This part gets very close to the maximum weight that can go into the furnace at one time. And that weight is dependent on the ability of the furnace to fully remove all of that binder material from the part. So that is a limitation. Generally we like to see parts like Nick said in that 150 to 100 by 100 range or smaller, but it doesn't mean you can't go larger in some scenarios and still be successful. Just some of our customers, when they try to go to that, to that larger volumes, you start to lose a little bit of the value potentially, just because the processing times can get long, the part costs can get a bit higher, that it starts to, you have to decide at that point, does it make more sense to print or does it make more sense to machine this part? And I don't think any of us here are trying to say that this system is going to replace all of your machining, but it does have a lot of applications where it makes sense to do that. And where that number falls is really in that 150 to 100 to 100 range generally. And that's just kind of a general rule of thumb. But like I said, you can go larger if it makes sense to, of course.
And then quick question on the costing data that you pulled or that you were showing earlier. What are those numbers sort of including, and if there's anything that's not included?
Yeah, so those numbers include typical consumable usage. So for a part, it's going to include the material, the metal powder, of course, the binder materials, as well as any consumables that the printer uses, the electricity that the printer uses. For the furnace, it's going to count all the gas the furnace is going to need to use, all the electricity the furnace is going to need to use, and any other consumables in the furnace. So really looking at all the consumables that are going to go into that part, as well as the electricity costs. That being said, if anyone on the line here is curious to know, what your parts would cost, or if I think they'd be good applications, feel free to shoot me an email, shoot me an STL or step file. I'm happy to run the numbers for you and let you know if it would be a good application for the Studio system or actually any of our systems. It's always good for me to look at different geometries and to let you know what I think about them. So.
Awesome. And then I think the last one that I'm kind of seeing here is around upgrades. So Studio 1 customers, will they be able to upgrade? What does that kind of look like?
Yep. So there is an upgrade plan. If you are a Studio 1 customer today, reach out to your reseller or your sales rep or to Desktop Metal customer support and ask them about that process. It is an upgrade to the printer as well as the furnace that will give them that added capability to run these new materials, and of course, still the ability to print those original materials as well. So there is an upgrade plan in process. So if you're interested in getting that access to that two-step process, definitely reach out to your sales rep.
And then we'll squeeze one more in. I got a couple on infill. Can you print fully solid parts? Is the infill required, and is there any sort of suggestions around that?
Yeah, so a large part of the thermal debinding time in the sintering furnace is going to be dependent on your part thickness. Because of that, there is a limitation to how thick your walls can be. I believe this is as thick as you can go, and it's a 5mm wall on either side of the infill. If you have a part that's thicker, you can crank up that wall thickness to be as thick as you can go, and then it's going to start producing that infill inside of that part. That's to ensure your part's able to be efficiently thermal debind. If you had a fully, if the part's smaller than this, you can do a fully dense part as long as you're within that 10mm thickness. If it's larger than that and you did want to make it fully thick, I don't think our software would let you, but what would happen is your furnace cycle could take, a week or longer, and that is not necessarily going to be successful for you. So that is the reason for that infill. That is the reason to ensure that those parts are able to be successfully thermally debound.
Great. That looks like pretty much the bulk of the questions. See
one more question here asking about the furnace. As you can see probably here, we also have the Desktop Metal shop system. Important to know that this furnace can be used for both systems. So if you decided you wanted a shop system and you also wanted a studio system, they could share a compatible furnace, which is a huge benefit of Desktop Metal in general, is that we provide that furnace for you. So that's a good question to answer. Cool. All right, well, thank you all so much for joining me. Let me jump to this last slide again, just so you can all have my email. If you have any further questions or want to reach out or chat or schedule a meeting to look at some of your applications, I'm always happy to chat with anyone here on the line or chat with anyone in general about manufacturing, about 3D printing. So thank you so much. I hope everyone's staying safe and having a good Tuesday. Thanks.